Hello all, this is Dr. Srilatha working as Senior Assistant Professor in the Department of Mathematics in Vallurpalli Nageshwara VIGNANA JYOTHI Institute of Engineering and Technology, Hyderabad. So today I'm going to explain about normal form, that is for how to find a rank of a matrix by using normal form. Now coming to the working procedure, so these are some steps we need to keep in mind whenever we are finding the normal form of a matrix. Here the order of the matrix, it may be of 4 by 4, 4 by 5 or 5 by 5, whatever may be the order of the matrix. We need to convert that matrix into normal form by implementing some operations. As previously in previous videos we discussed about elementary row and elementary column transformation. So here in normal form we will be using both row and as well as column transformations. Now coming to the first step, first try to convert the given matrix into normal form by using elementary row operations and elementary column operations. If the matrix is converted into normal form, that is, so here we are having the identity matrix I suffix r. So here I suffix r is nothing but the r rowed matrix. So R rowed matrix is nothing but, so here R stands for rank of the matrix. So R stands for rank of the matrix means if suppose by implementing the row and column transformations, if I got the identity matrix of order 2. So like this, if this is a standard form, now I can say that is I suffix r, where r stands for, that is r is equal to order, that is second order. So I may be mentioning here the rank of a matrix using normal form, which is equal to order of the matrix, that is equal to 2. Similarly, we may get either identity matrix of order 3 or identity matrix of order 4 and so on. So here the order r of the identity matrix gives the required rank of the matrix. So whenever you are using this normal form, you need to keep in mind these steps here. Now moving to problems. So here we are having one question, that is reduce the matrix into normal form and hence find its rank. So here if you observe, the rank of the matrix is 4 by 4 matrix. Now coming to the solution here. So first we need to write the given matrix, capital A equal to, so I'm writing the elements as it is 2, 1, 3, 4, 0, 3, 4, 1 and 2, 3, 7, 5, 2, 5, 11, 6. So this is a matrix of order 4 by 4. Before entering to the steps, just I will be generalizing one matrix here. That is, if capital A is equal to, I'm writing the generalized matrix A11, A12, A13, A14. Similarly, the second row elements as A21, A22, A23, A24. And the third row elements as A31, A32, A33, A34. And the fourth row elements as A41, A42, A43, A44. So here now coming to with respect to, so here we know already this is the first column elements, second column, and this is third column, and this is fourth one. Similarly here the first row, I'm denoting this as R1, the second row, and this is third row, and this is fourth row. So total we are having 4 rows and 4 columns. The first step here I am taking using the R1 element, I need to make all down elements equal to zeros with the help of row operations. This is my first step. Similarly, with the help of the C1, I need to make all these column elements, that is C1, C2, C3, C4, all should be equal to zeros by using column transformations. This is first step. So what I'm going to explain here, with the help of this R1, that is A11 element, I'm making all the down elements equal to zeros with the help of only row operations. Immediately, with the help of this C1 element, I'm going to make C2, C3, C4 all are equal to zeros with the help of column transformations. This is first step. Now coming to the second step, with the help of this A22, I need to make all the down elements equal to zeros with the help of row operations. Immediately, with the help of the C2 element, I need to make these two elements equal to zeros, that is C3, C4 are going to be zeros with the help of column transformation. This is second step. Now, the third step is with the help of this A33, I need to make the down element equal to 0 with the help of row operations. And immediately with the help of C3, I need to make this element equal to 0 with the help of column operations. So, except the diagonal elements, the above upper triangular matrix and the below lower triangular matrix, both are equal to zeros. That means what I am going to get here, except the diagonal elements, the below and above triangular, all elements are going to be 0. So that I can convert this into the identity matrix. It may be of any order here. So we need to get the normal form. It should be of the form I suffix r, where r is nothing but the r-rowed matrix, where r stands for the order of the matrix. So here we can define the rank of a matrix as the identity matrix, order of the matrix. So keeping in view all the above steps, now we move on to the example. So we know this is R1 here. I need to make all down elements equal to zeros with the help of row operations. So here R2 is by default 0. No need to make any operation here. Now applying the third row, I'm having R3 as 2 and R1 as 2. So 2 minus 2, this is going to be 0. So the transformation can be written as R3 tends to R3 minus R1, that is 2 minus 2, which is equal to 0. Next, R4 tends to, again I'm having 2, this R1 is also 2 minus 2, R4 minus R1. Now implementing the above operations here, A is approximately equal to, now write the first two rows as it is because we are not implementing any row operation to the above elements here. Now first coming to third row, this is going to be 0, 2 minus 2, 0, 3 minus 1, 2, 7 minus 3, 4, 5 minus 4, 1. Now implement R4 minus 1, this is going to be 0, 5 minus 3, 2, 11 minus 4, 8, and this is 6 minus 1, R4 minus R1, 6 minus 4, that is equal to 2. Just I made with the help of R1, I did the below all elements equal to zeros. Now the second with I need to make with the help of column transformations. Now applying C2 tends to 2C2 minus C1 and C3 tends to 2C3 minus 3C1 and C4 tends to C4 minus 2C1. Now this is approximately equal to, now write the first column elements as it is, that is 2, 0, 0, 0. Now here we are having, if you go back to the back slide here, so 1. So I'm doing here 2C2 minus C1, that is 2 minus 2, 0. Next I am doing 2C3 minus 3C1, that is 6 minus 6 going to be 0. And next fourth, that is 4, C4 minus 2, C1. So all these elements are going to be 0. Now this is, now apply the second column operations, which is going to be this element. The first element is going to be 0. And if you apply the same operation to the below elements, we'll be getting 6, 4, 8. And similarly, this is going to be 0. And this is applying the same operation. You will be getting the down elements here. And the fourth column is also going to be 0. And you will be getting all these elements. Now, just now I completed the first step. With the help of this A11, I did the all down elements equal to zeros with the help of row operation. And I did the all column elements, that is C2, C3, C4, all are equal to zeros with the help of column transformations. Now moving to second step 2 here, with the help of this R2 element, I need to make all down elements equal to zeros. Now what are the operations I need to implement here? Applying. So here I'm 4 and this is with 6. Now multiply this with 4 and this with 6. So that 6 4 is 24. 24 minus 24, which is going to be 0. Now R3 tends to 6 R3 minus 4 R2. Next R4 tends to, again I'm having 6. This is 8. Now multiply this with 6 and this with 8. So that 6 R4 minus 8 R2. Since I'm not implementing any operations for first and second row, I'm writing as it is 0, 0, 0, 0, 6, 8, 1. Now R3 is going to become 0 and this is the down element is also 24 minus 24. This is going to be 0. And now implementing this operation to the same row elements, we'll be getting 16 and this is 2. Now next fourth row, this is 0. Now this is going to be 0 here. Next implementing the same operation, you will be getting this is 32 and this is 4. Now applying Using that C2, I need to make the C3, C4 are all equal to zeros. C3 tends to 6C3 minus 8C2 and C4 tends to 6C4 minus C2. Since I'm not applying any operations to the first column and second column, I'm writing as it is 2, 0, 0, 0, 6, 0, 0. Now implement 6C3 minus 8C2. So this is already 0. Now we are making this element is equal to 0. And implementing the above operation, you will be getting 16 multiplied with 6, that is 96. And this is 32 multiplied with 6, 192. Now C4, again this is 0 and now this is going to be 0. Now multiply this with 6 here, that is 12 and this is 24. So we completed the second step here. Now the third step is with the help of this element, I need to make the down element equal to 0. Now applying R4 tends to R4 minus 2R3. Since I am applying for R4 row, I am writing the remaining R1, R2, R3 as it is. It's 2, 0, 0, 0, 6, 0, 0, 0, 0, 96, 12. So if you apply 96 here, 192 you are having here, multiplying with this, you will be getting this as 96 multiplying with 2, you are getting the down element is going to be 0 here. Now I'm writing this is automatically 0 and this is 0. Now this is going to be 0. Now implementing the above operation, you will be getting this element as 0. Now with the help of this element, I need to make this element equal to 0. Now applying, so what is the column transformation I need to implement here? C4. 8C4 minus C3. Now this is approximately equal to write the first three columns as it is 2, 0, 0, 0, 6, 0, 0, 0, 0, 96, 0. Now this is 0, this is 0. Now this becomes 0 and this is 0. If you observe, except the diagonal elements, the upper triangular matrix and the lower triangular matrix, all elements are zeros. Now we need to convert this into identity matrix. So how can you convert this into identity matrix? You may apply either row operation or the column operation. So here I am applying R1 tends to R1 divided by 2 so that it becomes 1. Next R2 tends to R2 divided by 6 so that it becomes 1. Then R3 tends to R3 divided by 96. You may apply column transformations by taking C1. C1 tends to C1 divided by 2. C2 tends to C2 divided by 6 and C3 tends to C3 divided by 96. Both are some. You may apply any operation here. You will be getting the same matrix. So this is approximately equal to 1, 0, 0, 0. 0, 1, 0, 0, 0, 0, 1, 0 and all the 0. So this is approximately, what is the order of this matrix here? Identity matrix of order 3 by 3. So if this is the matrix of order 3 by 3, now what is the rank of this matrix going to be become? So now I can write this is in normal form. Therefore, rank of a matrix is equal to order of the identity matrix. So what is order identity matrix? We got it here. That is 3. Since we will be denoting rank of A as that is row of A, that is order of the matrix is nothing but 3. So we got, so by implementing the above operations, we got the rank as 3. Similarly, we'll do one more example problem. Again, finding the rank of a matrix by using normal form. So keeping in view all the above steps. What are the steps we followed in previous problem? The same steps will be following here. So what is first step here? We need to implement applying. With the help of this matrix, I need to make R2 tends to R2 minus R1, 1 minus 1, that is going to be 0. Next, R3 tends to, since you are having 2, now multiply this with 2. R3 minus 2R1, so the 2 minus 2 becomes 0. Next, R4 tends to, since you are having 3, R4 minus, now multiply this with 3. This is approximately equal to, now write the first row elements as it is because we are not implementing any operation to the first row. Now this is going to be 0, 2 minus 1, 1, 3 minus 1, 2, minus 4, minus 1, that is minus 5. Now this is going to be 0, 3 minus 2, 1, and this is 5 minus 2, 3, minus 5, minus 2, minus 7, and this is going to be 0, R4, minus 4, minus 3, minus 7, and this is minus 8, and this is 5. So after immediately completing the row operations, we need to move on to column transformation. So what are the column transformations? So with the help of this element, I need to make all elements all are equal to zeros. Now C2 tends to C2 minus C1. Next, C3 tends to C3 minus C1. Then C4 tends to C4 minus C1. Now this is approximately equal to, now write the first column elements as it is, 1, 0, 0. Now this is going to be 0. Now apply the same operation to the above elements so that you'll be getting 1, 1, minus 7. And this is going to be 0. Now apply the same operations. This here you will be getting, this is 0, 3, and this is minus 8. Now this is going to be 0, minus 5, minus 7, and 5. We completed the first step here. Now the second step, with the help of this element, I need to make these elements equal to 0. I need to make these elements equal to zeros with the help of elementary row and column transformations. Now what are the operations I need to keep in mind here? Now applying, since you are having that R3 tends to, so both elements are 1, 1, R3 minus R2. Next R4 tends to R4 plus 7R1. Now implementing the operations here. R3 tends to R3 minus R2 and R4 tends to R4 plus 7R2. Now the given matrix is approximately equal to, now I am writing the first two rows as it is, 1 0 0 0 1 2 minus 5. Now implementing the operation here, R3 minus R2, this is automatically 0. Now this is going to be 0 here. Now implementing the same operations, you will be getting 1 minus 2, and this is 0. Now this is going to be 0, and this is 6 and minus 30. Now similarly, next the step is we need to go back to the column transformations. So what are the column operations I need to implement here? C3 tends to C3, this is 2 and this is 1, 2, C2. Next, C4 tends to, this is C4 minus 5 plus 5, C2. Now, since you are having for third and fourth row, I am writing the first two columns as it is, 1 0 0 0 1 0 0. Now, C3 minus 2, C2, this is already 0. Now, this is going to be 0. And implementing the above operations, 1, 6. And this is 0. Now, this is going to be 0. Now, implementing the above operations, you will be getting minus 2. And this is minus 30. Now, with the help of this element, I need to make this down element equal to 0. Now, what is the operation I need to perform here? Applying R4 tends to R4, you are having 6, R4 minus 6, R3. Now, this is approximately equal to, write the first three rows as it is, 1 0 0 0 1 0 0 0 0 1 minus 2. Now, this is already zeros. Now, this is going to be 0. Now, applying the above operation, you will be getting minus 28. Now, immediately next going back to the column transfer. With the help of this element, I need to make this minus 2 is equal to 0. Now, implementing or applying C4 tends to C4 plus 2C3. Now, write the first three columns as it is, 1 0 0 0 1 0 0 0 0 1 0. Now, C4 0. Now this element is going to be 0 here and the next element is minus 28. So if you observe the given matrix now here, we converted this into except the diagonal elements remaining the above, the upper and lower triangle elements all are equal to zeros. But here we are having minus 28. We need to make that element is also equal to 1. Now applying, you may apply either row or column. I am applying C4. C4 tends to C4 divided by minus 28. So now I will be getting the matrix which is in the form 1 0 0 0 1 0 0 0, 0, 1, 0 and 0, 0, 0, 1. So what is the order of this matrix here? This is a matrix of order, that is identity matrix of order 4. Now the given matrix, this is a normal form. Therefore, rank of a matrix is equal to, it is the order of the identity matrix, which we denote this as row of A. So what is the order of the matrix here? Which is equal to 4. So these are the models, whatever may be the models here you will be getting, how to for finding the rank of a matrix, which plays a crucial role in matrices. So what are the tips we are having? We are using both row and column transformations to convert our given matrix into normal form. After converting that into normal form, that means we need to convert that into identity matrix. It may be of any order. It may be of order 2, order 3, order 4 or order 5. Whatever may be the order. So we are saying the rank of a matrix is equal to order of the matrix. So that's all from this method. I hope you understand this one. Thank you all. Thank you for watching.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.